I want to take a second to discuss resonant chambers and why the position of an oscillator in a resonant chamber would be important for stacking sound waves. If you have a resonant chamber that's closed at one end, you'll always have what's called a node on the wall at the closed end. A node is a location of low pressure. The lowest fundamental frequency of a resonant chamber is the lowest frequency in which the chamber can sustain a standing wave, which is also called the first mode or first harmonic. As you can see here, a quarter of a wavelength will fit inside the cavity, leaving the antinode flush with the end of the cavity. This fundamental frequency isn't the only frequency that will create standing waves inside of the resonant chamber. All that is needed is for the node to stay at the back wall and for the antinode of the wavelength to stay flush with the opening of the chamber. Like you see here for the fundamental frequency, and here for the third, and for the fifth, and for the seventh harmonics. The third, fifth, and seventh harmonics of the fundamental frequency of the chamber are all resonant frequencies of the chamber. So where am I going with this? Well, I've always guessed that where the ancient Egyptians put these oscillators in the sanctuaries was no accident, and I wondered if it would be best to put an oscillator in the position of a node or an antinode inside of one of these sanctuaries. So I searched it. It turns out for the maximum effect, you need to put the oscillator in the position of an antinode, because antinodes are the points of maximum amplitude in a standing wave, which means that it'll give it the most freedom of movement. If you measure off the back of the sanctuary, and you line up that measurement with the first antinode of either the third, fifth, or seventh harmonic, you could figure out what harmonic the oscillator was positioned to be in, and maybe guess at what frequency it was tuned to.